Today, we'll delve into the Common Vulnerability Scoring System, or CVSS, which is the industry standard for scoring the severity of security vulnerabilities. Understanding CVSS is crucial for cybersecurity professionals as it helps prioritize responses to different threats. CVSS scores vulnerabilities on a scale from 0 to 10, with higher numbers indicating more severe threats. This scoring system works alongside the Common Vulnerabilities and Exposures (CV) database, providing a clear and standardized way to assess vulnerabilities. Think of CVSS as a tool that helps determine how serious a threat is and how quickly you need to respond. A CVSS vector is a text string summarizing the key characteristics of a vulnerability, including its metrics. For example, CVSS 3.0/AV/AC/PR/UI/S/C/I/E describes various aspects of vulnerability, such as the attack vector and impact metrics. The CVSS 3.0 part indicates the version being used, with modern systems primarily utilizing versions 3.0 and 3.1, although version 2 can still be seen in some contexts. Vulnerability scanners often summarize CVSS results using qualitative severity ratings like low, medium, high, and critical instead of just numeric scores. These qualitative ratings make the information easier to understand and act upon, helping organizations quickly prioritize their response efforts. CVSS uses 9 different metrics to rate the exploitability and impact of vulnerabilities. Each metric contributes to the overall score, providing a comprehensive view of the potential threat. Let's go through these metrics to understand how they work. The first metric is the attack vector, AV, which describes where a vulnerability can be exploited. It might be remotely exploitable over the network or require physical access to the device. Next is the attack complexity, AC, indicating how difficult it is to exploit the vulnerability. Low complexity means it's easy to exploit, while high complexity requires more effort and resources. Privileges required, PR, assesses the level of access needed to exploit the vulnerability. If no privileges are required, any user can potentially exploit it, while high privileges mean significant access rights are needed. User interaction, UI, indicates whether human interaction is required to exploit the vulnerability, such as clicking a link or opening a file. The confidentiality, C, metric measures the impact on data confidentiality if the vulnerability is exploited. It assesses how much unauthorized access to sensitive data could occur. Integrity evaluates whether the vulnerability allows data modification and the extent of that impact, assessing potential data tampering. Availability, A, measures the impact on system availability if the vulnerability is exploited, evaluating how much the system's functionality could be disrupted. The scope, S, metric indicates whether the vulnerability can affect components beyond the initial target, assessing whether an exploit could lead to further compromises in other parts of the system. Using these metrics, CVSS provides a structured way to assess vulnerabilities, helping prioritize actions just like assessing various factors in a military operation helps decide how to respond to a threat. In conclusion, understanding and applying CVSS is essential for effective cybersecurity defense. By using this system, organizations can prioritize their response efforts, focusing on the most severe vulnerabilities and ensuring a robust security posture.